Hey Franken friends, it's Greg Smith, aka Dr. Frankentosh, and today we're going to be looking at the hardware that I built for the Raspberry Pi Pico that drives the iBookintosh project. So stay tuned, we'll get started right after this. Hey, welcome back. So put my disclaimer at the front here. Please don't like this video, don't subscribe, don't click up there or down there, don't look at my other channels. Your time is precious, and thank you so much for spending part of it with me. And having said all that, let's get started. And I thought I'd give you a little tour of the iBookintosh prototype. As you may recall, what I'm doing is putting a MacBook Air logic board inside the case of an old iBook, and using the original keyboard, the original trackpad, and original display, original CD-ROM, as much as possible. So what you're looking at here is what I call the cadaver iBook. This is a deceased iBook that was given to me by another hobbyist, and so it was already dead when I got it. So deconstructing it, taking it apart, and so on made sense. And I've been able to use the keyboard and the trackpad. This is not the original keyboard or trackpad from this unit, to break down how these devices work. So let's talk about the keyboard. It is a matrix keyboard with little rubber nipples underneath, and very straightforward. The columns are roughly down here, down this here, and the rows are roughly across here. There's a pinout. So you can see here the pinout. It's a 40-pin connector, 20 pins, dual-inline. And in order to plug this in, I had to get a breakout board. And I got about 4 of these. And what's kind of ironic, this breakout board is a custom board that I got from Proto Advantage. Great company, the guy who runs it is excellent, does great work. But that's a $20 board right there, considering that the Pico that runs the whole show only costs about $4. You know, it's a bit of a expense. The board is a classic breadboard. The Pico and the ProVantage board are both mounted directly and soldered directly onto the board. And the reason is that I needed this to be as low profile as possible, and that was hard to accomplish. The board itself mounts on the original iBook chassis. These brass fittings here are original fittings. These are original screws. I could probably get another 1/4 inch if I took those out and tried to mount the board right on the plastic. So you can see here I've got a Pico probe plugged in to the single wire debug interface. And then over here, I've got a pinout for the UART so that I can send console output to the USB. I also installed a reset button, made my life a lot easier. And you may notice that I just apparently restarted it. So you can see the heartbeat is running. So originally I started with 22 gauge wire and quickly found that that was going to take up way too much space. So I just used it for power and ground plane. Then I switched to using wire wrap wire, which is about 30 gauge, and that gave me a lot more space. And I actually found it easier to work with. It turns out that a 30 gauge wire will actually fit through the pinholes of the breadboard. So that was a big advantage. One thing you may not see easily down here is the IC, and it's socketed, unlike these 2 boards, which I had to actually solder to the board to get it to be low profile. But this is the MCP23017. It is a GPIO extender, so it gives me 16 more pins. And if you remember, you know, I've got 40 pins to deal with. Now, we don't have to use all 40 of them, but it turns out that this matrix keyboard was set up with about, I think it was 10 pins as columns and 13 pins as rows. And when you consider that, you know, some of these GPIO pins are busy doing debug, then also I need a reset pin for the IC, 2 pins for I2C to control the MCP23017. I was running out of pins pretty quickly. And so the MCP23017 drives the rows on the keyboard, and then the Pico reads the columns. Now this, I'm sure this looks very suspect. This is a fan-made cover for the trackpad. And if you remember one of my earlier videos I did on the trackpad was for the original, I think it was, I can't remember the part number, but that board was a strict mouse emulator, and I needed something with more capabilities. So I stepped up to the TPS65, which is a trackpad that will allow multi-finger gestures. So I can do things like two-finger scrolling and such. And I don't have a connector for this. I'm going to get one. So I solder directly onto the board, and then that comes out here, and it's hard to see without taking the keyboard off. So let me just take the cover off. But you can see that I made a sort of a, right here, I made a connector that allows me to plug into the board, and that's got offset pins. So two things, the 2317 and the trackpad both run an I2C, which actually makes my life a lot easier. It only uses 2 pins. And as you can see, the USB goes out here. And so when you tap on the keyboards or you move the trackpad, the Pico converts all those keystrokes and mouse movements or trackpad movements into USB output, and then it goes down. That will eventually make its way to a USB hub, which will then be sent to a MacBook Air logic board. So the next step now is to add a display. I won't be using the original display that came with this unit because it was dead on arrival. I did get an upgraded display. I think the original displays were something like 800 by 600 pixels. The new display will be 1280 by 768, and I think it also has an LED backlight instead of the compact fluorescent light on the back. So I did create a schematic of sorts. This is the Raspberry Pi Pico. These are GPIO pin inputs. The Pico probe is connected to the GP01 and ground. Then I2C connects to the MCP23017, and I'm calling that XPIO. Then the 8 of the pins are connected to the keyboard connector, and then the other 8 pins are also connected to these off-page connectors for the keyboard. Then the columns, these represent the rows, these represent the columns, and the columns are connected to the inputs on the Raspberry Pi Pico through GPIO 5 through 15. Then over here is the trackpad, the TPS65. You can see here that it shares a reset pin with the XPIO. There's also a ready pin, which goes to GP18. What was happening here was that the trackpad was hard to pull, and I would pull it and there would be no data available. But this ready pin would indicate that someone had touched the trackpad and there was data available. And then, of course, SDA and SCL are tracked with the I2C. So that's pretty much it. It's a pretty straightforward design. So that's the broad brush overview of the hardware design. Soon I'll be adding on the USB hub, plus the display, and potentially a CD-ROM. So see you next time on Dr. Franken.